So yeah, this is me at my day job, detecting bugs, mostly in JavaScript. I currently work in Amsterdam at a company called WeTransfer, and I'm a front-end engineer and team lead there, which means a lot of different things in a lot of different companies. For me, that means I write mostly JavaScript, a little bit of Ruby, HTML, CSS, and I also manage a team of about 8 people, I think, at the moment, and I'm responsible for the delivery of that team. So this is also me. This is about 6 years ago when I was living in New Zealand, which is where I'm from, and yes, I'm a very, very long way away from home. But yeah, the idea was that we were running this coding workshop for a bunch of girls in the community to come in and see what being a software developer was actually like. And they were about 14 years old, and they were all in the same tech class at school. And honestly, I think we kind of blew their minds on what this career actually looks like, and I'm incredibly glad that I found myself here, and I want to encourage as many of them to get into doing this as possible. But the reason I tell you this is because they were also one of the inspirations for this talk. Because having worked with junior developers a lot, I've noticed that one of the things they really struggle with was figuring out how to debug. Because it's not something that we really teach people, right? It's like the skill that you're just assumed to be able to pick up as you go along. However, it's really, really important because we do it every single day, and there's so much to learn if you really focus on it. So hopefully there'll be something useful in here no matter how good a debugger you think you are. But I'd love to hear your thoughts also. On Twitter, I'm at Rebecca, and please feel free to tweet at me. So first, a quick look at the process itself. So how often have you actually spent time thinking about how you debug? It's easy to forget that it's actually a difficult skill to be mastered. It's learned over time and improved with experience, and it's not just about the tools you use, but about the process you take and the mindset you have. And this becomes really clear when we compare new developers and more experienced ones. Often newer developers jump straight in, they make changes to the code all over the place, they might have fixed something but they're not really sure, and they're not actually sure which part of the code they changed fixed it. And it's something, as I said, we do every single day. And so in this talk, I won't go into the detail of how important it is to reproduce the bug and being methodical and only changing one thing at a time and how to narrow down where the bug actually is, but it's surprising how often this stuff is not actually taught. And so if you're working with a junior developer or you are one, please take the time to really look at this stuff. So there is one step that I wanted to cover before I go into the tools, which even most senior developers I've worked with still forget to do, including myself. And that's just making your first step to be writing a test, right? Because it's the ideal way to keep you focused on just your one bug. It also speeds you up because you no longer need to launch your app and click through to get to the exact state where the bug is. And it also helps ensure your bug never returns, which is pretty useful. Okay, so let's move on to the tools, starting with the console. The polls are in. As you can see here, we have JavaScript Daily, and they've found out 56% of front-end developers use Console.log, and Chris Hallman, 67%. I mean, I'm going to take these with a grain of salt, but it's pretty safe to say that the majority of web developers use Console.log the majority of the time. And it's understandable. We've been conditioned to use it, right? Alongside simple text editors like Sublime Text, Atom, Notepad, etc. And a large portion of web developers, at least, have also really missed the exposure to a formal debugging process. And the browser console is pretty nice. You know, it works, so why change it? Well, because there is so much more. So, I mean, even if we just take a closer look at Console.log at first, you'll see that there's ways to optimize it. Here on the top, we have the normal Console.log usage. So we're just logging out these two variables. But actually, if we put it inside an object, then we not only get the value of the variable, but we also get the context of what it is, which is pretty useful, especially when you're logging a lot of stuff in your application. You can also really easily add styling to your logs. So including this %C at the beginning of your text and your styles in the second parameter, you can get pretty colors like this one here. And Console.table is really nice. There's a whole bunch more methods on the console object, and so I'm going to show you my favorites, but Googling will reveal a lot more. This is really useful if you want to scan an array of objects really quickly and compare and contrast. Console.group is really nice. If, you know, when you've added so many Console.logs in your application that you can't actually figure out where the one that you just added is, yeah. This is really nice for structuring those logs into collapsible groups and makes it a lot easier to figure out what's going on in the console. And another useful function you can use in the console is the $selector. So it works similarly to the jQuery selector. It's an alias for document.querySelector in the console. If you include a 0 after it, you get the most recently inspected HTML element or JavaScript element, a JavaScript object. A 1 gets you the second most recently selected, etc., up until 4, which is super useful if you want to quickly see what properties or attributes are on a DOM node or JavaScript object. And if you use the $, it's the equivalent of document.querySelectorAll. Okay, Console.traced is one of my favorites because it's really nice, especially if you're working in a new code base and you don't really know your way around yet, you don't really know how the files are structured. It's a really nice way to see what's calling your buggy functions. So here I added a Console.trace in this handle filter click function, the top one here, which is in app.js, which is the code that I was looking at. But I mean, this is a little bit of a fake example, but the idea is that like I couldn't figure out where that actually was being called in the code base. And so here you can see it was called in filter.js. And Console.dir is great when you want to inspect a DOM node as a JavaScript object rather than as its markup, which is what Console.log returns you. And on Node, it's even better because, as you can see, Console.log spits out objects all in black and white, and it only displays 2 levels deep. So on the geo property there, it just says object, which is like not that helpful. But if you put colors true and depth null into Console.dir, you get pretty colors, and you can also see the full levels of the object. So let's say we've been working with console functions for a while now, and you want to step it up. Well, let's dive into the dev tools. I'm focusing on Chrome here because it's what I'm most familiar with, but the Firefox dev tools are also really great. So, the dev tools debugger. One of the simplest ways to activate this is by using the debugger keyword in your code. When the browser hits that keyword, it'll pause the execution of your code and allow you to inspect it. So you can see here I've typed in the word debugger, and then the code is paused and I can hover over the different variables and inspect them. And I can also log out local variables in the dev tools here. And you can also check out the entire scope of the code at this point, which can be really handy. And the most important thing is being able to actually step through the code and watch it execute. So if you've never used a debugger before, here are your main options. They're pretty much the same no matter what kind of code you're debugging. First of all, we have resume. When you're on a breakpoint, pressing this will resume the script until the next breakpoint. If you hold this button down, you'll also have the option to play through until the code's finished executing. And then the next is step over, which executes the next function after your breakpoint and then stops. And then we have step into and out of functions. And note that these are functions that we're stepping over, into, and out of, not lines of code, which can be a little confusing sometimes. So what we've been doing here is adding a line of code breakpoint with the debugger keyword in our IDE. But if you set these breakpoints in the dev tools or in your editor, you'll see why this can be much more efficient than using Console.log. It's almost as if you've peppered your whole code base with Console.logs without actually having to do that. So simply click on the line number that you want to see more information about, and then you run your code as usual, and the execution will stop on the set line of code breakpoint, which you can then press resume to hit the next one, as opposed to needing to step through or over every single function. And when you're doing this, you may also want to use a watch expression, which is what we've got over on the right-hand side. And that'll give you more information about any given variable or expression in your code as it changes, as you step through it. So to define the values to watch, you click the little plus button on the right-hand side. And so here I've typed in this.state.mysteries. And so when I play the code, run the JavaScript, this the state.mysteries will update as it runs. So there's lots of different types of breakpoints. You can set these directly in the dev tools. We've got line of code is the one we've just been talking about, conditional line of code, which is really, really handy. DOM, so when DOM nodes change, XHR, so when your HTTP request contains a certain string, that's really handy. Event listeners, exceptions, and functions. So here on the left, you can see how to add a breakpoint for an event listener. So in this case, whenever you click on the website. And then up the top right is when a DOM node attribute is modified. And then the bottom one is a conditional breakpoint, which can be really useful for when a certain function, say a scroll handler or a React render, is called multiple times, but you only want to stop execution when something has a certain value. So here I'm creating a breakpoint that will only be hit if mysteries has some values in it. The idea being that when the app first loads, the variable will be empty because my API hasn't returned yet. But when it has, I want to see what the value is going to be. So click on the pause on exceptions button here on the right hand side if you want a breakpoint when there's an error. And the tick box to pause on caught exceptions can be really useful if you've got, especially if you've got a try catch that's swallowing exceptions that you don't want it to. That's caught me up a few times. When you have a bunch of breakpoints in your app, it can be useful to disable one temporarily while you're focused on something else, but you want to come back to it. And you can do this by just checking on the check marks in the breakpoint list. And in the debugging toolbar, you can also disable all breakpoints in case you want to just check how your app runs while you're making changes. And one tool that is really useful when using the debugger is blackboxing. So this lets us prevent the debugger from stepping into certain scripts when we're debugging code. So here I was debugging a React lifecycle function in one of my components, and I stepped through into the React DOM library. And I can be pretty sure that my bug's not going to be in the React DOM library, so I blackbox the script. This way that the next time I step through functions that come from this file, the debugger will just ignore it and I can focus on my application code. And you can also include file patterns in the DevTools settings over here. For instance, you could just blackbox everything from node modules, for example. So another useful trick when you're really unfamiliar with a code base is command plus backslash. So if you press this shortcut while JavaScript is executing, it will add a breakpoint to the code and stop executing right at that point. You'll be able to instantly see what's happening at the same time that you press the shortcut. And you can also now add log points in Chrome DevTools. So it's essentially a Console.log that you don't have to remember to delete from your code. The debugger won't pause on these points, but you'll get the results in your console as usual. And another really useful tool when debugging in the DevTools is the snippets option under the sources panel. So here you can save your own code snippets to run in the console. And there are great collections of snippets online. So one of my favorites augments the console with a function called Console.save, meaning anything you pass to it is downloaded as a JSON file, which is really handy, especially when you've got a big JSON object that you want to maybe open in an IDE or send to a colleague for taking a look at for some reason. Another useful tool is live expressions. So you can click this eye icon to type something into the console, which creates a live expression. And this pins it to the top of the console and it updates real time. It can be really useful for when something in your code needs to respond to something that's changing a lot, like window.width or scroll position, for example. Okay, so what about when you want to actually test some of your bug fixing hypotheses? A really great feature in Chrome is called local overrides. So we're going to go up here to the sources panel and click on overrides and set up overrides and find a folder on my desktop and select it and then give Chrome permission to access that folder. And then I can go into any website, and so here I'm on Reddit and I'm going to find out how to change the background color. And I'm going to change it to purple because why not? And then Command S to save it, and you can see there's a little purple dot now on the file. And now when I refresh, the changes are persisted. And this approach is really useful for when you want to make smallish changes to production websites in particular, when you need to figure out how to fix a bug really quickly and you have a pretty good idea of where it is. You don't need to have your local environment set up. You don't even need to have the original code on the computer. It can be done with just about any computer setup, right? So what happens if you want to go further and you want to make bigger changes that you not only want to persist on browser refresh, but also persist to your own project files sitting locally on your computer? Sounds handy, right? Well, the DevTools also have a really cool feature called workspaces. So here's a little app I made for calculating insulin dosage for diabetics, because I'm diabetic. And note that it's a production app on Heroku, not on my local host. And so I'm going to go to the File System tab now and add the actual project file that I have on my computer. And again, give access to Chrome. And now I can go and make some changes in the DevTools and save that with Command S and get my little, and you can see that it's been persisted to the actual files that are on my computer. And it goes back the other way as well. So if I save this here, then it appears in the DevTools. And so if you've got a project that you built with Create React App or Vue CLI, for example, you can actually just drag the entire folder into the sources panel and it will all work straight out of the box. It can be incredibly powerful, and in fact, some people actually use this as their full-time IDE. But it can be a little flaky, and it's still not as good as a full IDE in my opinion. In particular, it struggles with like more complicated build systems. So it kind of depends on what you're working on. If you like this idea of being able to persist changes on your production website, there's one last way I want to show you. So this is the concept of proxying your production files to local files on your hard drive, which is similar to workspaces, but without the DevTools persistence, but with a lot more cool features that better support those complicated build systems. So the simplest is a Chrome extension called Resource Override. So say you have a version of your application running on localhost. So I've got localhost bundle.js, and I'm mapping the production version of bundle.js to instead load the one on my localhost. So this allows you to change your code and test it within the larger environment where the bug actually occurred, which is pretty handy. Applications like Fiddler and my favorite Charles Proxy in the middle there also allow you to do this, but with a lot more features, including the ability to monitor and inspect all the calls that your website, in fact, your browser makes. I've been on teams that have literally used Charles Proxy for their entire front-end development flow. Many big applications can be really tricky to set up locally, and trying to keep the back-end architecture and APIs all up to date while also keeping it all up to date with the front-end developers on every single team, if you've got multiple teams, it can be really tricky and it takes a lot of time. But if you have a reliable staging environment, then proxying your front-end files was, for us, it was a really nice way to skip that setup entirely. So a lot of the technology I'm covering is either seriously enhanced by or doesn't work at all without source maps. A source map is a file that allows the browser or other technology to map the compiled and or compressed code back to its original file. It's another really important tool that helps with debugging. Minified code, as we probably know, is pretty difficult to decipher. On the top, we're inspecting a website without source maps, and on the bottom with. You can see all the variables have been mangled and the ES6 class has been transpiled. And on the bottom, it's way easier to figure out what's going on because it's the code that you actually wrote. So depending on your build process, it's pretty straightforward to set up. Here's the config for Webpack. At the top is the way to tell Webpack to choose to use its standard development configuration, which includes source maps by default. If you want more control, you can define it separately. I've chosen cheap module eval because I like the balance between speed and support, but your choice will depend on your use case. And then beneath that, we have the config for production. The only thing you really need is the DevTool property, but if you're using Uglify to minify your code, you'll want to set source map to true on that. And if you want to set the file name of your source map, you can do that here too. So when you build your project, you should see your source map file appear like over there on the right. So what about deploying source maps to production? I'm a big believer in doing this because production bugs are when source maps are their most useful. You're typically in a little bit of a hurry to decipher the code. And the good thing about source maps is they only get downloaded when the dev tools are opened. So they've got no effect on your application or its performance. And if you're really worried about people like being able to look at your source code unminified, keeping in mind that security through obscurity is like not a thing, then there's a pretty straightforward solution. You can indicate in the JavaScript file a source mapping URL, which is configurable with Webpack and other build tools, that points to the source map that's been uploaded to a different location that's only accessible by your team, say an S3 bucket that your company's VPN has access to. And if you're not able to set up source maps, say you're just being nosy and checking someone else's website out, it's surprising how many people do not know this. If you check this little thing here, you will make the code at least slightly more readable. Moving on now quickly to performance debugging. I don't have time to do it justice because this is just a massive rabbit hole, but I wanted to quickly illustrate where you can start. The key is to find the code you wrote in the Flame chat, right? If you click to open the main panel, you'll see all the activity that occurred on the main thread, including the execution of JavaScript. Usually a lot of stuff here is found in frameworks, but if you scan through the orange sections, you can see that your JavaScript files are actually in there. And in this case, it's my main.js file. And yeah, note this is a really basic one-page app, which is why it's so small. You can zoom in further and find the functions in your app and compare the time that they're taking with each other. Here we can see a call to append child and fetch, which are a lot more familiar to us. But the easiest way to debug an app's poor performance is by doing a performance audit. There are lots of great tools for this. Lighthouse, for example, which is in the DevTools. It's inside the audits panel. Here you can see the results on that same small one-page app. The best bit here is the opportunities section, which lists a whole bunch of different things, advice pretty much, for making the performance of your app better. The audits panel also allows you to audit other things like accessibility, which is really great. It makes something so important so much easier. If you follow the specific advice in the audit, your app will be so much more usable to so many more people, and in many cases improve the experience for everyone. Keep in mind though, there is no substitute for proper manual accessibility testing. So when it comes to debugging specific elements for the accessibility, the elements pane comes in handy with the accessibility tab. Here you can inspect elements and see which properties are correctly filled out. In this case, we're inspecting a text input. You can see that the name property is search, and this is what screen readers will read out when the user focuses on this input. You can see that the name was computed by looking at the placeholder property, and this input should really have a proper label or an area label, but at least it has a placeholder, so all users will now be able to know what it's for, rather than the screen reader just reading out text input, which is not that useful. Last thing for the DevTools, did you know that you can even debug Node in the DevTools? You just need to run your Node script with the inspect flag. BRK, by the way, means break before the code starts, so you can add your breakpoint straight away. Then either click on this green Node icon over here in the DevTools window, or go to Chrome/inspect and click on Open Dedicated DevTools for Node. If you like this workflow, you should check out the Node Inspection Manager extension, which manages all your scripts in Windows for you. So let's get on to the really good stuff. Integrated debugging in the editor has been around in various forms for ages, but many JavaScript developers are either not aware of it, they think it's too tricky to set up, or they don't want to change their debugging mindset because they don't think it's worth it. Well, I'll let you be the judge, but just make sure you give it a go first. Fortunately, we have a lot more front-end focused editor options now, some of which include an inbuilt debugger. I'm going to focus on VS Code because it's super light and fast and it's what I use every day. I'm not trying to sell you anything, that would be stupid because it's free. But other ideas like WebStorm also include an inbuilt debugger, and the idea is pretty similar. So I'm going to take you through my debugging process and how I set it up with a mini front-end React app that talks to an Express server. I've added a couple of spelling mistakes to simulate a real bug that you might be trying to fix. So a typical process for debugging a front-end application might look something like this. We open the browser and we see an error in the console. We go to the editor, we log out some of the variables that we think might be causing that error. Go back to the browser and refresh, or maybe we have a hot module reload, and if we're lucky, we've chosen a variable that helps us determine how to fix the bug. Back to the editor, make the fix, back to the browser, refresh, okay, great, fixed. Well, it's a hell of a lot of guesswork, right? And switching back and forth. Let's see how we can improve that flow. So VS Code has a bunch of extensions that let you debug tons of different languages and different configurations. The most useful for us is the debugger for Chrome extension. It's actually framework agnostic, so you could be working with Angular, Vue, whatever you'd like, but I'm going to show you the configuration for my app. So first, I'm going to go and download the extension, debugger for Chrome, install, and then reload VS Code. And now I'm going to go and add a configuration and pick the Chrome launch one. I just need to change the URL here to use port 3000 because that's what Create React App uses by default. And then I can save that and launch my app. And there you go, you can see it's launched. Absolutely no other configuration, no setup or settings, that was it. And the debugging experience is also really nice. So here we have a bug because on my beautiful app here on the right hand side, there's supposed to be quotes from each of these books. Mysteries? Yes. So what I'm going to do is go into my IDE, set a breakpoint, and refresh, and you can see the breakpoint's been hit, and now I can check out what's going on. Okay, quotes is undefined. I wonder why. If I go into the scope of the code here, I can check out the state and actually look at one of the objects, and you can see that it's quote. Okay, cool. So I can go and fix my bug, and I can remove the breakpoint, refresh, and hey, bug is fixed. And obviously I had the browser here to show you guys what was going on, but you can see that I didn't even have to touch the browser. It was fixed completely without that. Obviously it's a pretty fake example, but you get the idea. So before I finish, I should just quickly mention that in no way have I covered this space. I've obviously had to focus on one browser and one IDE, and I didn't even touch on mobile and network and service worker debugging, to name a few. There's so much more to explore here. And of course, accurate and realistic test coverage is an extremely important and useful way to prevent bugs in the first place. They provide a quick and easy way to test fixes and prevent them from occurring again. So, the last thing I'm going to leave you with is this. If you want to stick to the good old Console.log, then that is fine by me. I still use a combo of different tools, including Console.log. But please at least set yourself up with a good code snippet, because the number of people who I see typing out Console.log every single time, yeah, it's very easy to do this. This is what it looks like in VS Code. And that's it. Thank you very much.